So now we have learned that what is data structures and how it is important for a software developer. Now in this video, let's see what different types of data structures that we have. The data structures can be broadly grouped into two basic types, and that includes primitive data structures and non-primitive data structures. These groups are on the base of either predefined in the programming language or defined by a user. The data structures that are built in the programming language itself, which are available to the programmer, are referred as a primitive data structures. The most common primitive data structures are integer, float, character, string, or boolean. They are included in almost all programming languages. I have included definitions of these data structures in the resource section of this lecture. Another type of data structures is non-primitive data structures. They are also referred as user-defined data structures. Non-primitive data structures are derived from primitive data types by combining two or more primitive data structures. These data structures can be subdivided as linear data structures and as nonlinear data structures. So what's a linear data structure? In the linear data structures, the data items are arranged in memory in a linear sequential manner, and they can be either static or dynamic. In static linear data structures, associated memory locations are fixed at compile time. But in the dynamic structures, associated memory locations change. Here I'm not going to provide detailed information about these data structures in this lecture because we will discuss them very detailed in upcoming lectures. However, when it comes to nonlinear data structures, the data item is connected to several other items. They are not organized sequentially. Here it's possible for a data item to be connected with more than one data items. Graph and tree data structures are nonlinear data structures. As you see, we have various types of data structures. And you might be wondering, why do we need so many different types of data structures? So the answer is, each of these data structures has its own unique properties which work very efficiently in different circumstances. For example, graph data structures work perfectly for maps, and stack data structure works perfectly when you have backward and forward buttons in your application due to its first in last on nature. So hopefully you have understood different types of data structures that we have. And in the next lecture, we will look at different types of algorithms.